Right, in your instruction book, lesson 4 on page 28, we're looking at scientific notation. You've learned about place value and investigated multiplying and dividing by powers of 10. Now take a look at this problem. The planet Venus is more than 60 million miles from the sun. Write this number as the product of two factors, a number greater than or equal to 1 but less than 10 times a power of 10. Now, I have made you guys a video for this. You'll do this as homework tonight that explains the pieces of scientific notation. Part A says to write it in words. It is 60 million. If you wanted to actually do it right, I guess you would have said 60 million. Fill in the missing factor. That is 6 times, it would be 10 million. 6 times 10 million would make 60 million. Write the second factor in the equation as a product of tens. That means they want you to write 10 million as a product of 10. So 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000, times 10 is 100,000, times 10 is a million, times 10 is 10 million. Writing that second factor as a power of 10 would be 10 to the 1, 2, 3, 4, 5, 6, 7. And then part E says explain how you could write 60 million as the product of a number greater than or equal to 1 that is multiplied by a power of 10. You would keep the constant 6 times that base 10 of 10 to the 7th. Now that's kind of the long explanation of scientific notation. On the next page, they're going to go a little more in depth on that. Scientists often work with very large numbers, such as the distance from Venus to the sun or the number of cells in the human body. Writing and calculating with very large numbers can be tedious and inconvenient. When you wrote 60 million as 6 times 10 to the 7th, you used scientific notation. Now, this is in the video. Scientific notation uses exponents to make it easier to work with very large or very small numbers. To write a number in scientific notation, write it as the product of two factors. The constant, okay, this one is the constant. It is a number that is greater than or equal to 1 but less than 10. And then this second factor is the base 10. Okay, it is a power of 10. So you've got a constant and a base 10 that goes together to make these. To write 1,850,000 in scientific notation, you've got to change this 1,850,000 to a number between 1 and 10. Okay, it has to be less than 10, but it has to be greater than 1. So we're going to put the decimal between the 1 and the 8 to make it 1.85, a number that is greater than or equal to 1 but less than 10. And we have to account for all of these place values using the base 10, and they're going to show you that here. Original decimal is here, and we're going to move it 1, 2, 3, 4, 5, 6 decimal places to get it where we want it between the 1 and the 8. Our new constant becomes 1.85. We do not need all those extra zeros. Times the base 10, which will represent the 6 place values with an exponent of 6. So you're going to move the decimal point to get a number that is at least 1 but less than 10. And then the power of 10 is equal to the number of place values that the decimal point moved. The power doesn't tell you the number of zeros in the standard form of the number. Rather, it tells you the greatest place value of the number. To write 3.54 times 10 to the 5th in standard form, we move each digit in 3.54 up 5 place values by moving the decimal point 5 places to the right, because we are multiplying by 10 to the 5th. So you would take that original number. This one's changing the other way. We're going from scientific to standard. We're going to start here at this 3.54, and we're going to move 5 decimal places. 1, 2, 3, 4, 5. Now, in those gaps, you fill in zeros. That's where they got all those extra zeros, giving you 354,000. To translate between scientific notation and standard notation, change the place value of the digits by moving the decimal point according to the power of 10. Now, what you're going to find in your video is it is going to move that decimal, and it's going to show you when you're adding decimals, when you're subtracting decimals, when your exponent is positive, when it's negative. It's going to tell you how to do all that. We've got another example problem here. 6.85 times 10 to the 8th. They want this in standard form, which means get rid of the base 10. Now, our number is 6.85. The base 10 is positive, okay? It's a positive 8, which means that this number was originally very large. So we're going to take 6.85 and we're going to make it 8 place values bigger, okay? Positive is bigger. We're going to make it bigger than it is now. So 1 place value changes it from 6 to 68. 2 place values, now it's at 685. Do you see how the number's getting bigger? That's 2. We want to go 3, 4, 5, 6, 7, 8. Put your decimal point, then fill in all those gaps very carefully. You'll have to be neat with zeros. So the answer would be 685 million. All right, next page, on page 30. Read the problem below, then explore how to write very small numbers using scientific notation. Now, I just told you on the last page that very large numbers had a positive exponent. Very small numbers have a negative exponent. So you're going to be looking at negative exponents. Seven nanoseconds is equivalent to 7 1/billionths of a second, or 0.000000007 seconds. They want you to write this in scientific notation. Now, this chart, they are walking you through all of these place values and moving those decimals. They're showing you as a fraction with a negative exponent what that looks like. We are going to skip right over, nope, go down to the solvent at the bottom. You can write the number as the product of a number that is greater than or equal to 1, but less than 10 and a power of 10. Now, look at all of these zeros. We have to make this number 1 or more, but less than 10. Okay, one digit. You want one digit that is not 0 to the left of the decimal, which means we need that decimal to go on the right-hand side of the 7. Then we're going to count those place values. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, it was 9 place values, and because that was a very small number that we made bigger, it's going to have a negative exponent. Okay, a negative exponent is making the number, the small number, bigger. Number 2 wants you to write 1 billion as a product of tens. 10 times 10 is 100. Times 10 is 1,000. Times 10 is 10,000. Times 10 is 100,000. times 10 is a million, times 10 is 10 million, times 10 is 100 million, times 10 is a billion. Now they want you to write it as a power of 10. That would be 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9. That would be 10 to the 9th. Look at the table on the previous page. Write 1/1,000,000th as a 10 to a power. Complete the equation 7 times. Okay. So you've got, it would be 7 times 10. Remember, this is a fraction. If we didn't want it to be a fraction, we would give it a negative exponent. It'd be 10 to the negative 9. All right, looking at the solve it, which is where we started here, when you have to move the decimal point to the right to express a number in scientific notation, will the power of 10 be positive or negative? It will be negative. When you are making a very tiny, tiny number bigger, you are using a negative exponent. That decimal place is going to be moving to the right. When a number is written in scientific notation, a blank exponent means a number is at least 1, and a blank exponent means that the number is between 0 and 1. This would be positive. Positive exponents mean the number is 1 or more. Negative exponents mean that the number was between 0 and 1. Number 7 says is 2.14 times 10 to the negative 5th at least 1 or between 0 and 1. Because the exponent is negative, that number is less than 1. Okay, it is between 0 and 1. Number 8 wants us to write 2.14 times 10 to the negative 5th in standard form. Now they're showing you the long multiplication here as 2.14. I'm going to make this, I'm going to move 5 decimal places. Now it was negative, which means that this number was originally very small. We're going to make it 5 place values smaller. 1, 2, 3, 4, 5. Fill in those gaps, and that is your number in standard form. We actually answered number 9 in number 8. We've got 2 examples at the bottom, and then we'll call it a day. Write 63,120,000 in scientific notation. Guys, this is a very large number. Will my exponent be positive or negative? Very large number. It will be a positive exponent, and it's going to be 1, 2, 3, 4, 5, 6, 7. Okay, positive 7. And you do not have to show a positive. So 6.312 times 10 to the 7th. Number 11 is 9.054 times 10 to the negative 6. This exponent is negative, which means that my number is very small. We make it smaller by moving the decimal to the left. We don't want it to be 9.054. We want it to be 6 place values smaller. 1, 2, 3, 4, 5, 6. Fill in those missing zeros, and you see that this was a very tiny number.